A muon is an elementary particle that enters a region with a speed of 5 times 10 to the power 6, very fast, meters per second, and then is slowed down at a very high deceleration, 1.25 times 10 to the power 14 meter per second square. How far does the muon take to stop? So muon is just a fundamental particle, very tiny. So that's why it's moving that fast. Let's say this is our muon right here, very tiny. And it has a very high velocity. But that's initial velocity, so that's u. But it's also undergoing deceleration, like that, towards the negative side. And our frame of reference, our FOR, let's make this positive. This is positive, right? Just to write that down. So our velocity is positive, which is initial velocity is positive. What is it? 5 times 10 to the power 6 meter per second. And acceleration is going to be negative 1.25 times 10 to the power 14 meter per second squared. Okay, how far does the muon take to stop? How far? So I think we don't really care about the time, or can't input the time. So this equation really helps us. It's going to be v squared is equal to u square plus 2as, right? So we want to figure out how far it travels before it stops. So final velocity is 0. U squared is 5 times 10 to the 6 squared plus 2. It's going to be minus 1.25 times 10 to the power 14. Wow. And got to figure out s. So s will turn out to 0.1 meter in 10 centimeters. This muon is going to stop. For the second part, we have to graph distance versus time and velocity versus time. So let's bring it down here. Bring this down here. All right, so what do we have? What are we looking at? We are looking at distance versus time and velocity versus time. I think velocity is easy. You start at a very high negative value. Positive value. So kind of over here, end up going to 0. Acceleration is kind of constant. So you just try to connect these two lines together. And voila. Now what this is telling you is, okay, for the distance, this is a gradient. Whatever it is, it starts at a very low value, like 0. But you'll realize the gradient is going to be really high, and it's going to be really high until it reaches 0. So it's going to flatline. It's going to go horizontal, the graph, right? So gradient very high is going to be something like that. And over here, it's going to be something like that. So let's try connecting these two together. Kind of like that. Let's make it steeper. Kind of like that. Like that. Right? So over here, we can see that distance has a high gradient. This kind of looks like a straight line. Early on, I was just trying to connect the two areas together, but it's going to be more parabolic, right? Like a smooth uniform transition of gradient until it goes to 0. So just imagine there's a slight, maybe there is that curve. It's just hard to notice. So this is what the distance is going to look like. And we realize it changes very fast, very early, then stops changing when the time is up. Velocity is very fast, constantly decreases because there's a constant deceleration and goes to 0, and object stops.